Hello, everyone. Welcome to today's session, the Future of AI series, multi-agent and mixture of experts, workflows, and practical application. Do you follow the trends in AI? Are you hearing that 2025 is the year of the agents? Are you interested in how agents and agentic workflows can connect to your business to create a return on your AI investment? My name is Will Finney, and I'm a part of the business development and Avacia sales team. I'm joined today by Himanshu Shukla and Dave Comrie, who will be introducing themselves in just a moment. We hope you find today's discussion engaging and that we answer a few questions you may have about recent terminology around multi-agent workflows, mixture of experts, reasoning models, and how they differ, and when and how to use these techniques to their maximum effect. We'll explore the current state of multi-agent workflows with a focus on practical application. We'll also discuss the available techniques to reduce infrastructure costs and scale GPU usage efficiently for maximum performance. Finally, we'll look at some of the emerging AI trends and discuss the future of AI-driven applications. Without further ado, I'd like to welcome Himanshu from Siemens, who joins us as an expert in all things AI. Himanshu, welcome. Would you like to introduce yourself to our viewers?
Yeah, hi Will. Hi Dave. Thanks for having me here. Hi. So I'm Himanshu. I am working as an ML engineer at Siemens. So it's been about more than 1 year being into the field of machine learning engineering. I did my master's from India, and now I am in this interview.
Awesome. Thank you. How about you, Dave? Would you like to introduce yourself?
Yeah, thanks, Will. And really happy that you were able to join us, Himanshu. Dave Comrie here, Field CTO with Avacia. I've spent a lot of time in various industries across telco and as well now technology with the Avacia AI products that we're developing. So glad to be with all of you.
Thank you both for joining us. All right, we'll jump into the first question here. Himanshu, this one's actually more for you. Multi-agent systems are gaining a momentum in AI. Can you share with us how you involved with multi-agent systems? Were there certain challenges that drove you to that approach?
So starting from very initial, when I was involved into the models like large language models or vision models only, where we are providing an input and getting an output, like text to text, text to image, image to text, or image to image. Now the thing is that whenever we want expertise, like let's say code generation or grasping some content from an image or anything, we need separate models for that. So then a concept came, multi-agentic system. It is like the way we people think. Like if I'm expert on some creativity, I'll focus on that. If you are good at coding or designing, you will focus on it. So like this, we have multiple LLMs which are expert on their own field, which are fine-tuned on their own data set, and they have their own separate work. So this is where the multi-agent system came into the picture. Now I am working on the multi-agent system from last 8 months, where I figured out that operating the entire application, maintaining the workflow, or automating the pipeline, we can simply have a script where there will be some defined set of rules. There will be the things sometimes when, based on the scenario or conditions, we need to take some decisions. This is where the intelligence of LLMs comes into the picture, and we provide them a flow in which they communicate over each other and then provide us the responses.
Wow, that's phenomenal. Okay, moving into the second question here. This one's for both Dave and for you, Himanshu, as well. There's clearly a lot going into these architectural decisions and approaches. Maybe it would be good to take a step back and kind of clarify some of the buzzwords we're all hearing out there, such as mixture of experts or MO, multimodal, reasoning models or chain of thought, and how do they compare to multi-agent systems?
So, okay, they will start from it, then I'll.
Oh, sorry, much. Like just from like a very high level buzzwordy kind of thing. Like all these are circulating now out in the communities, and probably by the time this webinar is seen in post, we'll have like yet more terms that are coming out. AI is moving so fast. But really just to clarify kind of what these things are when we think about multimodal, really is just different types of input: video, audio, text, graphics, whereas chain of thought is more about how you're prompting models. So models that originally were very good at next word prediction, you could encourage better results out of them by telling them to do things like think step by step, which would kind of go deeper, encourage the models to go deeper. So it's kind of almost like a prompting type technique, to now where reasoning models are building that into the model itself. If you think about DeepSeek and then some of the things where the models tell you, hey, I'm thinking about this, they actually do better if you don't tell them to think step by step, because they're already doing that by themselves. And then this kind of bottom layer here, focus of our conversation today around multi-agent and mixture of experts. There's kind of two flavors, whether it's a bunch of experts independently or whether they're all in the same model. But Himanshu, why don't you take that a layer deeper for us?
Yeah. So should I start from here?
Yeah.
Okay. So, I mean, there is a lot of differences between the mixture of expert and multi-agent systems. Like you already provided a high-level overview that what the mixture of expert and multi-agent systems are. We already have it in first slide. Now, mixture of expert is a technique in which there are some layers of models which are interconnected with each other, and at every time, whatever the input we provide based on the selection, let's say if I'm providing an image, it will be provided to one of the expert, it will process it. Let's say I have some sort of statement. That statement will be breaking down to some points, and based on that, it will provide it to the separate experts. So not all the experts are working at the same time. They are not working parallelly. One expert is working at a time based on what the information is provided to a particular expert. Now, at the same time, multi-agent system is completely a different thing, where each of the LLMs or vision models are working separately, or they can work parallelly. Like we simply need to provide them the task, and whenever they got the task, they started working on it based on the instructions we provided. But where a mixture of experts are designed at the very first time, what they have to do, like in natural language processing, they simply improves the responses quality, but we can't say that it can do reasoning. If it is not designed to do reasoning, mixture of experts will not do the reasoning. But in the case of multi-agentic systems, we can have a combination of models which have reasoning, which don't have reasoning, which knows coding, which doesn't know coding. But in the mixture of expert, we have limited learning patterns only. So this is what the common differences are. And if someone wants to dive deep into this, they can go to this architectural and computational, all kind of differences, and it will help them to figure that out.
That's great.
That's interesting. Okay, on to the next question here. Himanshu, this one's mainly for you. In this LLM era, it seems models are becoming more powerful and serving more of a general purpose. But with multi-agent, we're engaging multiple stages in solving a problem. What is the benefit we're getting by going with a multi-agent approach versus just throwing bigger and bigger LLMs at a problem?
So these days, having bigger LLMs and having a multi-agentic system is both are separate things. So we know the LLMs like ChatGPT or DeepSeek, they are the large language models operating on more than 420 billion parameters or so. So they have a lot of knowledge, but sometimes we used to see that they doesn't provide us the proper quality of response, whatever we want. They are good at tool calling. So tool calling is something that, let's say, we say 3 into 2, which is 6. But when we say 1, 2, 3 into 5, 6, 7, 8, we need to pick up the calculator. At that time, LLMs uses the tool calling facility, which it creates the code dynamically, and then it calls that function, providing the numbers, and then getting up the output. So LLMs are good nowadays are doing that, like OpenAI or so. But when it comes to the multi-agentic system, they are powerful just because it comes with the combination of the large language models, small language models, or mid-size models, which can provide based on our use cases. So, I mean, you need to shift to the next slide so that I can explain it better. Okay.
This
After
one.
this, we had, yeah, you need to place it before, I think. So you can see that, yes, the large language models are powerful, but there are a lot of another models coming into the picture which are very good at the reasoning, like QWQ, which is 32 billion model parameter. And there is another which is Alibaba. They are coming again and again with the better quality of responses. So large language models are getting powerful, but now the mid-size or small language models are still very powerful. Now the thing is that we can save our expenses on GPU. We are not required to pay to OpenAI. We can have the third-party usage for these infrastructures, which will save our cost, which will be good for our privacy of data. We are not even need to provide that information to APIs, which will help them to train their models. But instead, we can do everything locally, build this multi-agent system. We can have the multiple LLMs. We can place them aligned. Like in the picture, you can see that this is a research team where first user is providing some kind of information, and then there will be one supervisor agent. Supervisor agent will decide that what it had to do next. So there are two responsibilities which supervisor LLM has. First one is research team, and second one is document authoring. Now, what research team is doing is invisible to what the document authoring is doing, and document authoring isn't aware that what research team is doing. They all be communicated with the help of supervisor. Supervisor will have all of kind of data. Research team is doing the research, doing the web scraping, curating all the data, restructuring, reformatting, providing it to the supervisor. Supervisor will forward the information to document authoring. Document authoring will do the writing, note taking, and everything, and then it will be provided to supervisor and then to user. So you can see that there is not only a single model. We have an entire research team for which we provided information that they have to do the web scraping, they have to search the data, then they have to gather everything, they have to restructure it. And then another side, we have another LLM which got the task of doing the document authoring, where writing, notes taking, chart generation will be done. So on this round shaped circles, we have tools, and that square shaped are the LLMs, except that user one, where they are handling the task based on their own expertise. So these are the LLMs, or we can say small language models as well, where we are taking into the picture. So if we say that a single model can do everything, no, it is not possible. It is like a team. Supervisor is manager here, research team is the team members, where they are using their tools, and then they are delegating the process to each other, and then they're working on that.
Wow, that's very cool insights. And I think this next question we have kind of ties into that a little bit. As with human-based teams, coordination of multiple parties can be complicated. What are some challenges you've seen with things like task planning, data sharing between agents, failure recovery, etc.? Maybe also touch on which parties of the workflow still require humans in the loop, and what does human interaction kind of look like with the multi-agent systems?
Okay, so one of the most common terms which is buzzing around, that AI will replace the humans entirely. No, that is not the thing. We call them as a co-pilot. Co-pilot means the one who is helping us. We are the one who is driving the entire project, and co-pilot will be there to help and to remove that manual work. So every time we need to provide some supervision or some sort of input from our side as well. Let's say if I am building a project, I provided the entire prompt to a model, it generated the insights, the project structure, the files which are going to operate, how to run everything. But when we come it on running practically, we used to see that there are a lot of issues running that. Now at that time, human in loop are required. So there will be always a demand of humans because humans are very good problem solvers. And still, I think AGI is very far away from now. So we can say that AGI will come into the picture and replace everyone. Still, it is working on some artificial set of instructions which is revolving around those neural networks, and it is still asks help for the humans. Now how they can be helpful in team or something, like I missed that last part where you asked that just a second. Just a second, I
Yeah,
have
like
read
what
the
is
question.
like is there human interaction during these
Yeah,
like as you go from the research team to the document authoring in this
yeah,
example, can you insert humans into the flow?
yeah, it is required. So let's say when we are searching for a topic, I ask to generate an application where I will judge an LLM based on the questions I have. Now it can mess up with that, with the keyword judge, and it can come up with another documentation or another kind of approach. At that time, we need to provide some clarification. So step by step human in the loop interaction is required. Let's say it built the entire application correctly, but it is not what we want, or there are some errors whenever we are trying to execute the application. At that time, we need to provide the context, or we need to provide some of the fixes manually. It will help you to generate the body, the body of that code, but sometimes you need to provide some your own expertise on that code. You need to do some things manually, so you can't entirely replace those, but yeah, it will help you to eliminate that things. And like in multi-agentic system, we every time we create a multi-agent system, like the way we see our team. So in a team we have manager, then the set of people like 6 7 8 people are there. They have their own tasks, they are coordinating with each other, they have their own set of tools, they are working them within themselves. Like the way we have multi-agentic system, we are simply trying to mimic everything whatever humans are doing in their real life. So as they are machines, we are trying to make them behave like humans, but it's still they can't because they are machines simply. So
Yeah, it makes sense. Like, if you think about, assembly line production is kind of like workflows, and it's kind of like an assembly line. Like you do, like in a real world, say like a manufacturing scenario, like you want to sample, right, different parts and check quality at various stages. I can see where that sort of you'd want to have that in this model where maybe you're sampling some of the outputs from time to time, or even having like other agents like do that quality control at these checkpoints. So after the writer is done with the first draft, you could have another LLM that's specialized in reviewing that, set up with like a different prompt context, kind of providing those quality checks. So I agree. Like humans need to like implement this structure and say, okay, this is what I want, or at least have that description, that sort of exertion of like will onto the system of this is what I want to see, this is how I want you to operate, and then the systems can kind of react to that, maybe to build out the structure, but certainly to carry out the tasks within the structure.
Yeah.
Good insights on both of you there. It's also interesting to think that you need that human element. A lot of people nowadays that aren't really familiar with all types of AI are assuming that it'll take over the world and however long. But it's nice to know that you need that somewhat of a human element.
Yeah, always.
Based on my experience, like it still takes a lot of doing to get the to whip those models into shape, and still like a lot of teams are having to put a lot of effort into creating these systems. So that definitely they're not taking over the world quite yet.
Yeah,
a little bit of time.
Nice. All right, this next question is actually for you, Dave. Planning workflows and multiple agents can imply some tricky infrastructure scheduling problems. Having the right GPUs with the right data sets available to keep workflows flowing, to avoid bottlenecks, latency, system thrash, etc., is a key concern in multi-agent systems. Maybe you can talk about how a little bit of Avacia's technology helps teams who are working in this kind of setup and facing these challenges?
Yeah, and that's core to kind of Vacia and what we do. So when we look at tasks or workflows, we think about breaking workflows down. A multi-agent is like follows this kind of archetype where you've got tasks that flow to other tasks, agents that flow to other agents. So underneath all of this, as we know, there are computers, right? Servers in the cloud or on your premises that are processing these. And carefully orchestrating that infrastructure is going to become quite important. If every time you need to use a new agent, you're having to like drain off a GPU, reload a model onto it, launch a new pod process, like that can take time. And so your workflows that are designed to be efficient. I mean, if you think about, back to the, assembly line type thing, if each stage in the assembly line, you had to like remove the machine and put a new machine in place and then do the next step and then take that machine out and bring in a new place. Well, you don't do that, right? You just stage these machines in sequence and in order. So that's the same type of concept here, except we're staging data and staging like the LLM models onto these different stages so that they're ready, meaning that as one task or one agent is handing off to the next agent, that next agent is already prepared with the context that it needs to operate on the next step. And what we were finding is, Himanshu mentioned some of the tools call outs and other things that happen. Like not every step in these workflows requires a GPU. So you can look at reducing your infrastructure cost by intelligently knowing, hey, this step needs a GPU, this step does not need a GPU, and trading those off, inserting the right infrastructure at the right time into the right workflow to kind of handle the task at hand. And that's where our software platform takes all those different things into account, as well as the scalability and the cost tracking of all of this. So, gosh, how much is this sort of purple slice costing me, right? Is there a particular process in here that's very expensive that maybe I want to go, fine tune or tweak a little bit to make it more efficient? Maybe this task that's running on a GPU is horribly inefficient in terms of the GPU. We're running it on a super heavyweight GPU, and it doesn't need that. It maybe just needs a much smaller GPU shape. So all of those things, when you're fine tuning these, contribute to the overall cost effectiveness of the solution.
Great insights there. All right, following up. Next question is, let's get practical for a moment and take a bit of, okay, restart there. Let's get practical for a moment and talk about a bit about use cases. There are common areas where you see multi-agent systems being used, like robotics, manufacturing, software development, and sales automation.
Yeah, so was that for me?
For both
Yeah,
of you.
go for it, Himanshu.
Yeah. So there is one of the most practical use case for the multi-agent system where we have a software, industrial software, I can't name because it is Siemens proprietary. But what we are doing, that we created an agentic system where we are providing an input with the help of a UI. That UI is taking that input. Then let's say I'm not a good prompter. I am very good at providing the prompts to the machine. But now I trained a model such a way that it knows that whatever the user is asking, I need to restructure the prompt based on it. After that, it will be provided to the script generation agent. So my first agent was who is reprompting the script and making it better and contextual. Second, that script will be provided to another LLM, which having expertise on creating the code bases. So that will taking by that LLM, then it will create the code, and then there is another LLM which is doing a kind of tool calling which will execute that script, and then there will be a loop. If there is error in the script, it will come back again to the script generation agent. Those error logs will be taken. If required, there will be some human intervention. Another step is that it will generate the script again, it will execute it, and after executing it successfully, it will come up to the feedback and another additional question if humans wants to add something, and then it will come up to the final responses. This is what the multi-agent systems are doing. This is how they are empowering the uh, legacy software which my company is using right now. And this is how the AI is helping to save a lot of time in doing this manual work, where now the experts are now busy in doing more creative tasks, like how they can enhance the software, how they can do more with that. I mean, on industrial side. So now they are not more concerned about execution or coding and everything, but they are more concerned on the use cases and how they can make things much more better for that. So this is how they are. I mean that multi-agent systems are doing best in their way.
Yeah, those are good ones. And like, I think my examples would be almost more very practical and maybe relatable to folks and how they're using different tool sets already, and maybe not thinking about it in a multi-agent context. But I find myself, if I'm looking at product or kind of creating product requirements, I'll use everything from ChatGPT as kind of that co-pilot ideation stage to quickly flesh out frameworks and kind of get some like a skeleton kind of in place, and then layer in details with that. I might use like a Vercel v0 to prototype some user interface elements to kind of give a quick high-level snapshot of what these ideas are. I may go into Cursor and do some quick code development to analyze maybe existing code base. So already I think a lot of people are familiar with multi-agent in terms of how they're using these different tools that are out there. The multi-agent practice now that Himanshu is gauging is taking those different processes and putting more automation around it. So it's not necessarily an individual selecting the different tools, but now the system coming together to select those different tools and different agents kind of through the workflow. So that's how I think about it, to kind of relate it back to what maybe people are doing in their everyday lives.
Yeah, the automation seems like it plays a big factor into all of this.
Yeah.
It does, and it's not just software. It's for sales teams. You want to maybe have like a lead gen agent where you're scraping data and working LinkedIn contacts and figuring that kind of lead gen piece out, to the marketing side where you're trying to get certain messages out there. These are all specialized tasks that are as all of our inboxes will tell you, are becoming more common because we're just getting inundated with a lot of information. I'm waiting for the agent that's going to help read all that stuff and like sift out the important things that I might care about. So still waiting on that one. But teams are clearly using this. I think there's a risk of it becoming just noise, which it already is. So there's a problem there to be solved, I think, in the industry, of how this multi-agent workflows can help us manage information and get the right information to the right person at the right time that they need it. That'd be great.
Yeah, that would be very helpful. Okay. The next question is just for you, Himanshu. On the technical side of putting this into practice for people just getting started to build multi-agent systems, which tools, platforms, patterns, or frameworks, etc., would you recommend?
So one of the easiest way to build is the QAI. QAI is open source repository which anyone can use. So they use the isolated Docker container for executing any coding task or anything, which will avoid the errors. Second is AutoGen from Microsoft, which is a very good tool for building the multi-agentic system. And there is third one, which is introduced in the course of small agents, like using LangGraph, LangChain. LangChain is one of the most popular tool for it. So if someone wants to learn, CrewAI, LangChain, and AutoGen are there, and these are the best tools. And recently, Google has announced one of the Firebase Studio, who I mean, they are helping to build the multi-agent system without having any coding language or anything on it. It is completely no code platform. You just need to be a good prompter. But if someone wants to go into the core or dive into the coding, get their hands dirty with the code, they can go with QAI and AutoGen. It will be good for them.
Cool. Very practical.
Very practical, yes. All right, our final question. This one's going out to the both of you here. Looking ahead, what excites you the most about the space you're working in? Where do you see these trends around multi-agent and mixture of experts connecting to practical work streams? Also, how do you think that they will evolve in the coming months?
So, starting from me, things will evolving. Like, we have smaller agents, like it is not entirely replacing the large language models, but the smaller models are coming to the picture. They are doing pretty good. Like OpenAI Suban Mini is lacking behind in front of that Alibaba models like Qwen or QWQ models. DeepSeek, when DeepSeek came, it disrupted the entire market, and OpenAI was facing a lot of issues in that time. So things will change. And another thing is that the technology which we are using, which is transformers, will get replaced by other tools and technology. So researches are going on for achieving the AGI, but I think transformers will not help to get that AGI completely. So there are some another things which are going behind with the help of researchers, which will replace this LLMs and transformers completely. And the future trends will be a lot on problem solving. Humans will be hired based on their problem solving. So we need to be a good problem solver. We need to be very much structural and modular in terms of expressing our ideas and everything. And I mean, can't predict the entire trend, but yes, we will be robust if we are good to have some sort of problem solving challenges. We need to be evolve ourselves as well. That will be good. It's like I've seen a post on social media in which a girl is saying that I want AI to do my dishes, laundry, and everything, and I'll do the creativity like article writing and everything. I don't want AI to do write article for me or do some creativity work for me, and I'm doing the dishes. This is how AI will replace. But now you need to put that AI to work in such a way that you should be upskilling up yourself every day, and AI is doing the task which is saving your time simply.
Yeah, I love that idea, like upskilling yourself. And we'd be remiss if we didn't talk about MCP at all during the call.
Yeah.
And I know that like what, probably 6 months ago, like this wasn't on anybody's radar, but now like you can't turn around without kicking over an MCP can somewhere. So like talk a little bit about MCP and kind of what this is unlocking for people. Himanshu.
So one of the most common examples which is provided on the website of this Claude Anthropic website, they says that MCP is like a USB Type-C hub by which all of the phones can be charged or all of the phones can be connected. Like we have one USB-C, iPhone, Android, and all of the devices are now have that Type-C port to communicate with one of the other devices. So like same, we have MCP. We can connect to any of the local database without compromising the privacy and everything. We can connect it with the online sources, web scraping, everything. We can connect it to LLMs. We can do anything with the help of MCP. MCP provides us a lot of flexibility in terms of integrating the data source, integrating the tools and everything. So this is one of the most basic explanation of what MCP is doing. MCP simplifying the multi-agentic system and integrating the tools, storage, databases to it.
Yeah, it's great. And that concept of like LLMs having a little tool belt that they can like go utilize for different tasks and call out. And the cool thing, not not having to like instruct the LLM exactly what to do, but for it to figure out by introspecting all the different services that it has available to it, and then figuring out kind of what it's going to do with those things. And back to your question, Will, like the things that are exciting or excite me, I think it's just the pace of change is very exciting to me. Things are like you take like a week off, if you go on vacation and come back, like things are going to be different. And that rate of change is creating so much opportunity in so many different industries, things that like you wouldn't expect to be impacted by AI or being impacted by AI, from Main Street to Wall Street to all of our jobs and all of our kind of like lives. Like if you read my ChatGPT history is interleaved with both professional and personal kind of stuff, where it's just kind of baking into all these different areas of our lives, and for me at least providing value. I feel like it's taken each of us and given us an opportunity to turbocharge some aspect of our lives, whether that's professionally or like creating vacation agendas for us, or like doing these like simple things that maybe are just brain drains that yes, I don't want to think about. And if you find that doing the dishes robot, how much you let me know, because like I'm all in on that. So
Yeah.
fantastic.
And,
Other than the dishwasher, I guess, kind of does that, but you still got to put them all in there yourself.
I have a suggestion, like when you talked about privacy, just go to ChatGPT from a personal account from which you are using it already. Just ask based on my previous responses in the new chat. Based on my previous responses, give me good things and bad things about me and roast me based on that. And see how it will tell me everything about, it will tell you everything about what you are doing on those threads, and whatever you provided. Based on that, it will provide entire of information about you. So this is how they're storing your information, whatever you are providing. So it is not safe, but in this MCP, your data will be in your local computer only. It will not be compromised. This is what they are providing in this MCP.
Oh, I had a very Orwellian sort of 1984 moment there as you were describing that.
Yeah.
Wow.
All right. Well, let's leave it there, Will.
Okay. So to conclude, we've explored how multi-agent systems and mixture of experts are reshaping the AI landscape, from solving complex problems more efficiently to optimizing infrastructure and GPU usage, to driving real-world applications across industries. As we've seen, the promise of agentic workflows lies not just in their technical innovation, but in their practical ability to deliver real returns on AI investments. A big thank you to Himanshu and Dave for sharing their insights and experiences today. We hope today's discussion gives you clarity on the emerging trends and inspired new ideas for how to bring them into your own work. Thank you both, Dave and Himanshu, for joining us.
Thanks, Himanshu, and thanks, Will.
Yeah, this was great.
Thanks for having me. I also felt very nice sharing the information, what I'm doing in Siemens. I took example from that and tried to explain the content in very simpler form. So thanks. I also enjoyed the session.
Yeah.
Great.
To learn more about other products, please visit www.avesha.io. Thank you.